Hey everyone, we're going to finish up 7.4 with the rejection region method. So these are the steps. Steps 1, 2, 3, and 6 are all the same as before. So really it's these steps 4 and 5 that are different. So I'm going to redo some problems that we've already done. Let's take a look at this example number 2. I've already started it because we've already done that, right? The HOHA and finding the Z are the same as before, right? So I just pulled that information from the problem we did in the last video right there, okay? So what's different is when you go to find the p-value, we don't find a p-value, you find critical values. That's the big difference with the rejection region method. So sometimes my math lab is going to ask you for p-values, sometimes it'll ask you for critical values. So how do you find a critical value and what do you do with it? So what we do is we could use this little table right here because this is a left-tailed test and alpha is 0.05. So if I just go 0.05 left, there's my critical value, negative 1.645. I can jot that down. Critical values are always notated by a sub-zero. And then what you do with that is you draw it. The best way for rejection regions is drawing them. All right, so that's a left tail. All right, and the critical value is right there. All right, and then I'm going to plot the standardized test statistic that we find from the formula, which notice it's further in, right? That negative 2.2 is further in the shaded area. And when that happens, we reject H sub 0. Right? Or the way my lab I think sometimes says it is reject when the Z is less than Z sub 0. Right? Because here these are all values that are less than the Z sub 0, which is the negative 1.645. And then your conclusion is going to be the same, right? HA is the claim, reject, so sufficient to support. And we've done a lot of those, so hopefully that is making sense how to make the final conclusion. There is sufficient evidence to support the claim. Okay. You can also do this in StatCrunch, and StatCrunch will give you that critical value, and that's actually really useful if there's a alpha that's not in this little handy table. So if you had something like 0.04 or some kind of weird level of significance, then use StatCrunch for that. And the way to do that is we'll just go to stat, and this is proportion stat, one sample with summary. Now here in this one, we are given the number of observations. That was the 100 in this problem. And it said that 39% have access. We have to actually find the number of people, though, in this one. But if it's 100 times 0.39 is still 39. So 39 would be the number of successes. And then perform a hypothesis test. Just make it look like what we just did. Yeah, we were actually using 0.5. But just make sure we have a less than on the HA for it to match. And then show that critical value. That'll give you that critical value that my lab will want you to enter. And then I can hit compute, and I get that negative 2.2 that we knew about. The negative 1.645 is that critical Z, the Z sub 0. I also get the p-value, which I don't need if I'm doing the rejection region method, but that's another way to get all those figures. Okay, so I think that's pretty good. We'll try one more. Let's redo example number 3. So for example 3, we had, that's the one where it was 0.025. So H sub 0 was that for the claim. HA was not equal to, it was a two-tailed test. I'll copy the Z because I don't want to have to redo that. Z we got as negative 1.31. And then now we need the Z sub 0 critical value. So again, I'm not getting the p-value, I'm getting the critical value. So this is a 0.1 level of significance and a two-tailed test. So I can go to my little table, 0.1, 2, there it is, plus or minus 1.645. So for two-tail test, you should have two critical values because there's two tails. So I'll just write that as plus or minus 1.645. Okay. And then I do my rejection region method. So I would draw this one as two tails. On each tail is one of those critical values. So there's the negative one there and the positive one there. And then now where is the negative 1.31? So that looks like a little short. Like negative 1.31 would be something like there, right? So this would be a fail to reject. If it's not in there, that's it. And then same conclusion. Let's see, HO is the claim, so that's a reject. Fail to reject, insufficient. So insufficient to reject. There's insufficient evidence to reject the claim. And there you have it. How does it look in StatCrunch? You can pull that up real quick. Let's just go close that out, redo it. So again, it's under stat, proportion stat, one sample with summary. Here, the number of successes, remember, was 42 because it's 21% of 200, and sample size is 200. So I did do this in the last video, and that's 0.25 right there. And then click that show critical value, and that would be the setup, compute. And there's the critical value. Oops, what did I do wrong there? I forgot to get the right level of significance. So for showing the critical value, I always forget to do this. I've probably done it in the previous video and you're like, did you forgot it? Yeah, make sure to get that right level of significance if you want to show the right critical value. So the level of significance is 0.1 in this problem. Yeah, and now it's good. Now I can click compute, and there I get my correct critical value, 1.645. Now it doesn't give you that plus minus, so I do have to remember to put that on there when entering things into MyLab. But that works out pretty nicely. Get the Z-stat and all that. Okay, so that's that. Otherwise, I hope all is going well. That's the end of chapter 7, so give all of that a try. If you have questions, send me an email. Otherwise, hope it's going well for you. Thanks. Talk to you later.